Hello dear friends, what's up? You are most welcome in this beautiful lecture. Today I'm going to teach you very interesting topic that is isomerism from the journal Organic Chemistry. You see the twins from external structure, if we see the external structure look like same, but their attitude, their behavior is totally different. So these are called isomer of each other. Now let us define what do you mean by isomerism. Isomerism means the compound having same molecular formula but their physical and chemical properties are totally different. They are known as isomer of each other. And this property is known as isomerism. You can see the molecular formula C6H12O6. Glucose and fructose both show the same molecular formula, but you see the structure. Glucose contain aldehyde group here, CHO, but in ketone there is C double bond O, ketone, totally different. You see another example, that is C3H6O. One compound is acetone having the same formula and another is propanol, that is the aldehyde. So these two compounds have same molecular formula but their physical and chemical properties totally different. Now let us move for the flow chart for the isomerism. Actually, isomerism can be categorized mainly in two parts. Number one is structural isomerism, means the compound having same molecular formula but the structure is different. We will discuss these about the structural isomerism later. Next one is stereoisomerism. The compound having same molecular formula but the arrangement of constituent atom, ion or molecule in 3D space is different. In 3-dimensional space, they are present a different position, x, y, z, 3-dimensional. Structural isomerism further can be categorized into 6 sections. Number 1 is chain isomerism. Number 2 is positional isomerism. Next is functional, and the fourth one is metamerism, tautomerism, and last one is chain isomerism. We will discuss these one by one. Stereoisomerism can be categorized in 2 sections. One is geometrical, another is optical isomerism. Now let us discuss about the chain isomerism. Compound having same molecular formula but the number of carbon chain is different. For example, C4H10. C4H10 gives us the butane. We can write the structure here, CH3, CH2, CH2, CH3. This is butane having general molecular formula C4H10, and we can also draw CH3, CH3, 2-methyl propane. So these two compounds have same molecular formula but the number of carbon chain, one side is 4 and in second one compound is 3 carbon main chain. Now let us discuss about the positional isomerism. Very easy to define. Compound having same molecular formula but the position of the side chain or functional group is totally different. I repeat, compound having the same molecular formula but the position of side chain of functional group have different position in separate compound. For example, C5H12. You see the structure, C5H12. First one is pentane 3-ol. In this is pentane 3-ol. This is pentane 2-ol. In this one is pentane 1-ol. You see the position of alcoholic group OH, and this compound is situated at the 3rd carbon. In this it at 2 carbon and here at carbon number 1. So what is different? Different is the position of OH group. We can draw one more structure here. You see very interesting compound. This is the benzene. We can draw easily like this, and I'm drawing here the OH functional group at this position of OH. Suppose I change the position of OH group from 2nd position to 3rd position, then you also draw the structure in your copy, please. This one, OH. What is this? 1,2-diol, benzene 1,2-diol. This is benzene 1,3-diol, but the common name is totally different. This is catechol. This is catechol, and this one is a resorcinol, and totally different according to the name. So now let us move further for another isomerism, and that is the functional isomerism. Very important out of these 6, functional isomerism. Compound having same molecular formula, but actually the functional groups are different. They are known as functional isomer of each other. For example, C3H6O. C3H6O, we can draw the structure. One will be CH3, CH3OCH3. This is ether. CH3, CH2, CHO. This is propanol aldehyde. Suppose we are having CH3, CH2OH. What is the general formula of this compound? That is C2H6O, having 2 carbon, 6 hydrogen and oxygen. And also we can draw the same, CH3OCH3, having 2 carbon, 6 hydrogen, 1 oxygen, but it is ether, it is alcohol. So alcohol functional isomer is ether, and for ketone, the functional isomer is aldehyde. It is CH3CO, CH3CO, The functional isomer of acid is ester. For example, we can draw a structure one more here. That is CH3. I'm drawing a structure here. CH3, yes, CH3, CH2, COOH. Suppose we have, and we can draw CH3, COO, CH3. So what is the molecular formula? That is C3, H6O2 in both the cases. But one is here the carboxylic group and another is ester. Now let's discuss about, I'm erasing this molecule so that I can draw here. I want to erase the compound from this position because I want to draw one more. Okay, let's move further. Metamerism. Metamerism means it is very special isomerism. Only few molecules show this kind of isomerism. Compound having same molecular formula, but the position of nitrogen or oxygen atom that change in the compound. For example, for metamer, for example, we are having CH3, CH2, CH2OCH3. This is methoxypropane, and we can draw CH3, CH2OCH2CH3. This is ethoxyethane. So what is the main difference between these two structures? The difference is the position of oxygen atom, but this is not called the positional isomerism. No, this is the metamerism, because the oxygen atom shift inside the chain and break down the chain in different form. Like in first one, there is a 3 carbon in the main chain. In second one, there is 2 carbon in the main chain. First compound IUPAC name is methoxypropane and second one is ethoxyethane. Now let us move for the next. That is called the tautomerism. What is the tautomerism? A tautomers of a compound refer to the isomer of the compounds which only differ in the position of proton and electrons. Typically, the tautomers of a compound exist together in equilibrium and easily interchange. It occurs via an intermolecular proton transfer. An important example of this phenomena is known as, it is also known as ketoenol tautomerism. So let's draw the structure of tautomers. For example, we have CH3, CHO. We can draw the CHO like this. There was a single bond between the carbon-carbon, and it can interchange like this. CH2 double bond, CH single bond, OH. One hydrogen from the alpha carbon that moved to oxygen atom, and the pi electron from this position they shift to the alpha position. But there is a must condition to show this isomerism is that there should be free alpha hydrogen availability. free alpha hydrogen, and the second one is that alpha carbon should not be attached with the unsaturated bond like double bond or triple bond. So it is the necessary condition to show the tautomerism. The next one is ring chain isomerism. In ring chain isomerism, one of the isomer has in open chain structure, whereas the other has the ring chain structure. They generally contain a different number of pi bond like C3H6. One compound is in C3H6, the one compound is propene, another is cyclopropane. We can draw a structure like this: CH3, CH double bond, CH2, propane, and the second one is cyclopropane. I hope it's clear now. Now let us take an example for the exercise. For you especially, draw the structure of all isomers having molecular formula C4H9Br. How you will draw the structural isomer of C4H9Br? So let's draw with me. 4 carbon in a chain. First we make, and there will be 3 carbon, 4 valency, 3 carbon, 2 carbon will be here, and 2 carbon will be here, and we are making CH2Br. This is 1 bromobutane. We have to change the position of bromine from 1 to the second one. Okay, erase this one. There is only 1 carbon, 1 carbon, 2 carbon. It becomes the 2 bromobutane. Now, after 2 bromobutane, we are making this 2 methyl CH3, 2 methyl, 2 bromopropane. And one more thing, we can draw a structure like this, CH2Br. Now it will be the position number 1, and then 2, and then 3. So it will be 2 methyl 1 bromopropane. So there are 4 isomer we have draw here. Now the next one is very interesting question. For a molecule to show tautomerism, it is compulsory that it has free alpha hydrogen, and it should not be attached with sp2 or sp3 hybridized carbon, because sp2 and sp3, you know that when carbon attached with the double bond, its hybridization become sp2 if it contain 1, 2 and 3 sigma 1 pi, and if there is triple bond, so hybridization is sp, because there is 2 pi electron. The carbon atom should not be attached, alpha especially, because alpha carbon is responsible to show the tautomerism. There should be free alpha hydrogen, and it should not be attached with the sp2 or sp hybridized carbon. I hope that you enjoy this lecture. Stay tuned. Please press the bell icon. Don't forget to share it. Thank you very much. Waiting for your response. Thank you very much.